Today's date is Friday, February 19th, 2019. Oh, check this out, guys. 19, 20, 21. What do you think of that? What do you think of that, Brian? Pretty awesome. Pretty awesome. If we had 18 months on our calendar, it would be 18, 19, 20, 21. It's pretty interesting. It's good stuff. You can use that if you want. Okay, what I was just explaining to these people is we did this problem yesterday, and when we first looked at this problem, we looked at the toolbox, we noticed that there were two methods that would work, two tools that we could work right off the bat. One of them was to manipulate and substitute Pythagorean identities in for squared terms. Oops. And that is actually what we did. Okay? We took cosine squared out, and in its place we put 1 minus sine squared x. And then we distributed and simplified these sine x's out. Okay? So we did one substitution, and you see the red arrow. This was because I used this whiteboard over here as my margin, and then I drew back in what I was substituting for cosine squared. Okay? And we end up with this. But we did recognize from the beginning that because of the way this problem is set up, we could factor this expression. So that's what we're going to do down here. This is our alternative method. How do we know we can factor? We know we can factor when there is more than one term. Meaning, we have a product in one space, then a plus or a minus sign, and something else on the other side. Any situation that we have that, and there could be more, right? There could be more terms. We know there's the potential to factor. So what we look for in this product and in this term here is anything they have in common. And if you're thinking, yeah, they all got x's. The x's aren't going anywhere. Okay? We said from the beginning of this, we have to treat the trigonometric package. And when I talk about a trigonometric package, I mean this, okay, is a trigonometric package. This is a trigonometric package. Okay? This is a trigonometric package. We have to treat the trigonometric package as the variable, not just the x. Okay? So when we look at this, all right, I'm going to clear this up because it's getting kind of crazy. What do they have in common? They both have one of these. So I'm going to factor that away from both of those expressions. So the sine x gets factored out, and anytime we factor, right, we pull that out and then we put the parentheses and write what's left. Well, what's left after I take away this sine x is a cosine squared x. What's left after I factor out a sine x? You can't say nothing. We have to have a placeholder there, okay? Because what is factoring? Factoring is division. We're dividing out that term. So I'm dividing out. We say take away. Take away is kind of like subtraction, but we're taking it away from that term. We're dividing it away from that term. If we're dividing this by sine x to get it out, what's sine x divided by sine x? It's 1. Right? Any term divided by itself is equal to 1. So now we have this statement. So there's our factoring. Now we look at this and we see if there's anything we can do. Now don't make the critical mistake of looking at that and saying, all right, well, what can I do? I don't know, I guess I can distribute. Well, what would distributing get you? The exact same thing that we started with. So distributing would undo the factoring we just did. So that's not going to help. I can't actually subtract these, so I'm kind of stuck. There's no quote-unquote math or simplifying I can do. So what do? I come back to the toolbox. And I go through this list again. But we'll fast forward this one, okay? There's no fractions. There's not 4 terms. Anything that involves dealing with fractions we can't do. Okay? write everything in terms of sine or cosine. Can't do that because I already have. It's already been done. Okay, we just did this. We just factored. So if you get rid of all the things you can't do, there's only one thing you can do, because we have that squared term. So we look at this and we say, how am I going to manipulate a Pythagorean identity to get this? Right? And here we go. We're going to go into the margin again. Oops. And in the margin, we realize that we have cosine squared x minus 1. So we start with this Pythagorean identity, and we do the manipulation. The manipulation is moving it around, right? Moving pieces to fit, to make it work for us. I said this in the opener, didn't get it on video, but now that the camera's rolling, I'll say it again. If you are a manipulative person, you use other people to accomplish tasks for you. You make them think that they're doing something for themselves when they're actually doing it for you. That's what a manipulative person is. They view other people as objects that they can control. When we say manipulate the Pythagorean identity, we're going to make it work for us. We're going to make it do some work that fits our agenda. And our agenda is getting this. So, how do we get that? Well, it starts by getting the minus 1 together with the cosine squared x. Starts with that. So now this says sine squared x plus cosine squared x minus 1 equals 0. Because 1 minus 1 is 0. I just write it. Here it is. Here it is. Okay? But it has to be all by itself. I need this to say cosine squared x minus 1 equals something. Which means, what's the difference between that statement and that statement? This statement has the sine squared here. So, I'm going to keep manipulating this, and I'm going to subtract the sine squared x away from there. And when I subtract that, then I am just left with this. And 0 minus sine squared x is negative sine squared x. So now I have my equivalent statement. Now I can, this was the manipulation, now comes the substitution. That goes in place of this. So we come back into our problem. Oops, I always missed that the first time. Maybe I need to recalibrate this thing. So in here, I'm going to put negative sine squared x, because that's what it's equal to. On the outside, I have sine x. And how do I clean this up? Or how do I math this? What can I do now? Now I can actually multiply these because they're similar terms. The variable, the trigonometric package is the same. This is 2 of those. Here's another one for a total of negative sine cubed x. And I don't know if I'll be able to get these on the same viewing here. There we go. We got that up here using that method, and we got it down here using this method. Ta-da!